Welcome to today's webinar, Scaling Traffic Operations with Agentic AI. This is part of the Connect Me webinar series, Agentic AI and Traffic Engineering, from data overload to defensible decisions. I'm Pete Croswell, president of Croswell-Schulte Information Technology Consultants and an adjunct instructor with Penn State University. I'll be moderating this event and hosting the QA and some interactive discussions that we'll have after our distinguished panelists finish their presentations and demo. I've got over 40 years of experience as a government employee and a consultant in GIS in a range of IT domains, including transportation planning, ITS, infrastructure asset management, and other disciplines. I'm a past president of URISA, now the Geospatial Professional Network, and I'm active in many professional and research education activities. And I'm really looking forward to this webinar, in part because my professional background goes way back to some of the early work in intelligent transportation systems and applying GIS technology and other IT tools to this discipline. This webinar will focus on the use of AI tools in traffic management, not as a replacement for human talent, but as a force multiplier to help manage and make sense of the huge amount of data that supports real-time traffic management and also supports longer-term traffic planning and decision-making. Professionals involved with traffic monitoring and operational management are handling huge quantities of data from multiple sources in a multimodal transportation environment: road, rail, water, air, public transit, and of course, pedestrian, foot traffic, and bicycle traffic as well. Professionals are being asked to oversee larger and more complex transportation networks and data sets that are often siloed on different platforms. So that's the premise for this webinar. The presenters will describe and illustrate concepts, tools, and techniques for use of targeted AI tools for traffic operations management to address these challenges. And why is this so important? Because it has so much to do with operational effectiveness, doing more with fewer resources, the efficiency of traffic flow, people and vehicle safety, just meeting the demands of businesses and the general public. The order of events here in the webinar will be presentations by two presenters that I'll introduce in a minute. We'll have a demo, and we want to bring up kind of a roundtable discussion, get your ideas on some specific topics. And we'll have a general QA session and some final words from the presenters, and then we'll close it off. We've got up to 90 minutes available for the webinar. So before we get started, we'd like to run a quick poll of the audience to find out where you are from and what industries and sectors you work in. So the poll will pop up on your screen. There it is. Please fill that out now and hit submit. We'll go through the results here in a minute. And as you're responding to that poll, I'll say a few more words of introduction and housekeeping. In addition to hearing from the panelists, an important objective in this webinar is to get your active participation. And you can do this by entering a question or comment in the Q&A space you can access from the bottom of your screen. Please note that the chat window is disabled and also your mics are muted during the webinar. There's no need to raise your hand. You can post a question or comment at any time in that Q&A space, and the presenters will respond to questions at the end of the session. Again, so post those questions at any time. And if you are addressing a question to one of the two presenters specifically, please note that in your question. Also, during the presentations, we're going to have several additional polls that will pop up. So we'd like you to get your response to those as well. This session is being recorded and will be available for download on demand after the event. And you'll get receive an email notifying you when that recording is available. We'd like to thank our webinar series sponsor for putting this on. This is Miovision, and for making this educational opportunity available to you. So before we proceed, let's take a look at those poll results. Okay, looks like we've got a large number of respondents, 57% from local government, 14 from state governments, representation from industry at 14% and other at 10%. Where are the participants today from? We've got a large number from the US, 5% from Canada, and another 10% or so from around the world, Europe and Africa. Business sector, 17% land public administration, 56%, not too surprising, in transportation. We've got others in public information, public works and utilities at 11%, economic development at 6%, and a few others. And then finally, the population size of jurisdictions represented in participants today. 5% at under 25,000 population, 11% 25,000 to 50,000, 21% 50,000 to 100,000, and we've got 63% jurisdictions over 100,000. So thank you very much for filling out that poll. Let's proceed with the introductions. Today's featured presenters are all representatives of Miovision. And if you're not already familiar with this company, you should be. Miovision has a successful 20-year history providing modern tools to address today's and tomorrow's challenges in traffic management. Our first speaker today will be Gavyn McLeod. He's the Director of Product Marketing with Miovision. He's got 20 years of experience in the tech sector, and for Miovision, he focuses on the future of intelligent mobility at the intersection of agentic AI and traffic network data management. Gavyn has deep-rooted experience helping organizations extract meaningful results from complex data ecosystems and use of advanced AI analytics. He's a frequent speaker and strategist and excels at distilling high-level technical concepts into clear, impactful narratives that resonate with global audiences. We've also got Brent, who is the Director of Solutions Engineering at Miovision. He's got about 20 years of experience in local government and the private sector in a variety of technical and customer support roles. At Miovision, he leads the team that transforms transportation data tools into real-world product intelligent traffic management systems. These presenters are knowledgeable and well-respected experts with many decades of experience in traffic engineering and management and related disciplines. And they've got a deep and practical understanding of traffic management and the use of AI tools in this domain. So I think you'll be very interested in the presentations today. I'd first like to bring up Brent to do a little introduction of Miovision. Brent?
Hello, everyone. Thank you for joining us today. My name is Brent Rogerson, as you heard. I've spent lots of time in the transportation industry. Most of my career has been at Miovision, supporting and building tools and applications that help us address common challenges across all of our agencies today. And those can relate to congestion type scenarios. They could be safety related. They could be more adaptability. They could be pedestrian or vulnerable road user related. And we develop a unified data platform or an intelligent mobility platform that connects a lot of these components together. And Miovision has spent a lot of time, about 20 years, building these products and partnering with many cities across the globe. We're currently in about 68 countries, partnering with our customers and our data collectors and our agencies, which amount to about 5,000 customers now, which is a great range of different types of challenges across the world. So this allowed us to build out this network that allowed us to learn from different types of regions and learn from different types of areas that really maximize what a unified platform could do. And so, just as an example of that, you can kind of see some of the agencies that we work with. There's probably a lot going on here, but it gives you a good range of kind of the departments and the teams that we've learned from over the years. Traffic engineering and planning, they focus a lot on the data collection, the optimization of timing plans, and the optimization of our complex demand requirements of dense urban environments or even rural arterials. But they do a lot of data collection to achieve that. Then we work with our traffic operational groups. The traffic operational groups, they are often focused on maintenance and operations, so signals working the way that they should, dispatching technicians and electricians, making sure that the lights are on, quite literally, and operating the way that they should. This allowed us to build out a connected ecosystem that connected in public safety. So our peripheral services and our emergency services that keep everything operational and keep us all safe, like public safety. So think police department and fire departments. They need to navigate our networks and navigate our roads and get where they're going as fast as they possibly can, while also being as safe as they possibly can. So helping them work their way through the network and create optimized routes for them. And then finally, transit. More and more do dense urban environments need alternate options than vehicles on the road. We need multimodal approaches. We need active transportation, but we also need public transportation to help minimize the need for vehicles directly. So we similarly help these transit agencies be reliable on their schedules and keep moving forward so that the general public can leverage the public transit as much as possible. Across all of these different communities, across all these different departments and agencies, we have learned quite a bit around unifying their data sets and helping them tackle different challenges. So that's a quick introduction on Miovision, and maybe we'll get into the next little bit here shortly.
Okay, thank you, Brent. So again, Gavyn and Brent will cover useful information about the use of AI for traffic operations and management, with the tagline of this webinar, "Stop managing data, start managing outcomes." They will discuss some practical ideas and methods and tools for applying AI to traffic problems. So again, please participate by posting a question in the Q&A space. And now it's time to get started. So Gavyn and Brent, over to you.
Thank you, Peter. Maybe I'll let Gavyn jump in here, and maybe Gavyn, you can kick us off.
Yeah, thanks, Brent. We have a pretty exciting agenda for you today, I think. So we're going to start by talking about industry trends and challenges, really dive into what's driving the problem today so we can really wrap our heads around what we're trying to solve with the different tooling. We'll then talk about Gen AI and AI specifically. We'll kind of get into the different components of AI, demystify what Gen AI agents are and how they can be applied in transportation. We'll also spend a good amount of time talking about the barriers to agentic AI adoption for traffic teams and how you can overcome those barriers safely and responsibly. We'll open it up for a roundtable discussion and some Q&A if we have any questions in the Q&A section around frameworks for responsible AI adoption. And then we're going to do a sneak peek of a product that we're launching in the week and a half or so, Mateo, which is our Miovision Gen AI agent. Brent's going to be able to show that off to you, talk about some customers who are already using Agentic AI in their systems, and kind of show you where the rubber meets the road, and then show you that this isn't just hype and talk, that this is real, this is happening, and it's here. So Brent, with all that, really excited to get going. Why don't you kick us off?
Awesome. Thank you so much. So why does this matter now? Why are we really launching this into the industry in a much more meaningful way? It's less about the collection of data now. So now we're in this moment in time in the industry where a shift is about to occur. We're right at a turning point of the way we've operated historically and the way we need to move forward. Many of the agencies that we have worked with, and many of you can probably relate to, is we spent the last maybe 2 decades investing in data, investing in systems, investing connectivity, software, sensors, detection, you name it. We've invested in it, and we've outfitted our infrastructure in various many ways. Obviously, not completely. There's still a lot of work to be done there. But now many teams are in this scenario that even though we put this large investment into the infrastructure, it still feels very manual. It still feels very disconnected, fragmented. We're still reacting to citizen complaints and issues, very similar to how we've done in the past. And the shift needs to occur now. So we're now in this moment where we have an opportunity where we can start applying tools and applications like Agentic AI. All the data is there. This is the most exciting piece of the challenge. There is an amazing amount of data that's been produced across our networks, and now we can take advantage of it. We also know that the pressure to improve our city streets and our complex demand is growing significantly as well. So we're seeing this large demand for complex resolutions across competing demands. Think vulnerable road users are trying to use the same roads as movement of goods now, and that's creating almost a complex shift in how do we solve a problem. But what is missing across all of the different vendors, all of the different architectures, and all of the different cities is a common operating layer, a operating system, if you will, across all these data sets that allow us to leverage the investments that we've made. And that's really what we're here to talk about today. We're going to really look at what changes when AI moves beyond this chat interface. Think some of the interfaces that we're maybe using in our day-to-day work life, like Gemini or ChatGPT, those types of things. As we move beyond a chat interface and we start integrating agentic AI into the actual general productivity and the actual engineering work that we're doing to accelerate the duties, we're going to see an exciting shift in how that's applied. We're going to be finding context faster, correlating information across systems significantly faster, ultimately reducing the time that we need to spend on investigations and making it easier to really translate this complex data into public value, make our streets safer and better. So this session, I want to be clear, is not necessarily about products or specific tools. It's more about the concepts. We're not suggesting it's about replacing individuals or functions or engineers. This is really about operational leverage. This is really about how do we actually take advantage of the large amount of data that we have and spend less time managing that data and more time managing that outcome. So as we get deeper into this information, we'll pull up the first poll that we have from the agentic AI perspective and start thinking about what is the biggest drain on your operational capacity today. So think about your day-to-day operation, and we'll let you select from the options here. So switching between multiple systems is a common thing I hear. Manually extracting data and assembling context is a common activity that you see cross-departmentally and cross-jurisdictionally. Often just trying to find the root causes, the root issues within the data and actually trying to understand what the data is telling you, so chasing that root cause. Or finally, just translating all that deep technical engineering work and outputs that we create to non-technical stakeholders. Think the political landscape, the public hearings that we all participate in to make sure the public is aware of what is actually happening and resolving the citizen complaints that are happening. So we'll give a second to make sure everybody has a chance, and then once everything is selected, we'll take a quick look at the results. So I don't know if that's been collected enough. Oh, there we go. So we saw quite a good cross-section of data there. It's actually almost equally balanced across all four of these items. 29% switching between multiple systems, 29% manually extracting data and assembling content, chasing root causes, 21%, and 21% translating technical outputs for non-technical stakeholders. So it's interesting that that is a almost equal problem across all of those. So great, thank you for providing that. All right, so going deeper into the information here, the operating model is already starting to shift. Like we're already starting to see the mounting pressure on safety. Most transportation master plans today have safety as the number one desire, the number one outcome that we need to achieve. We do know for a fact, and there's been lots of research papers that indicate this as well, not just the safety components, but also the complexity of dense urban environments. People are moving towards urban environments more continuously, and we're seeing that show up in multiple different data sets and multiple different reports. There was a recent report from AASHTO that had a white paper that actually tried to break down some of these data points and how they're identifying how they're going to start tackling some of the data and where agencies actually see AI that can actually help with the challenge of these network size complexities, the fragmented systems, the manual analysis and data that we all have, while also trying to manage shrinking or flat budgets or flat staffing scenarios. So the problem is getting more complex, but the human resources aren't getting any larger. So this white paper that we saw through AASHTO recently talked about how agencies are already thinking about how AI can be applied. And through that survey, we saw that 38% of government organizations are already in a pilot phase of AI. So this isn't something that is new in many ways. It's actually what people are already starting to undertake, and agencies are already starting to think about and starting to pilot within their organization. 77% of those agencies have also seen a significant opportunity in operational management. This seemed to be a common thread that we saw in both the research analysis in the market today, as recent as January 2026, which was just a couple months ago. Some of this information is starting to come out, and we're starting to see where the opportunities are within the community. And then 78% of traffic professionals find it very time consuming to action insights from this data. There is a large amount of data that's been generated, and now it's about how do we actually use this data to create outcomes. So we're gonna work our way through how this could be applied, what some of these terms mean, and start building towards how we can apply it in the world. So very excited to bring this topic to the group here and see some of the comments along the way. So I'll pass it over to Gavyn, and maybe you can start digging deeper for us.
Yeah, I want to dive a little bit more into this problem, right? So Brent alluded to the fact that we have this paradox of more data, more visibility, more digital capabilities than ever before. But what we're seeing in the reactions from teams is that they still do not feel like they have more capacity. Yet there's still the pressure to improve safety and mobility while budgets and staffing are not increasing in parallel. So traffic agencies have invested heavily in their sensors, their signals, their cameras, telemetry, analytics, cloud platforms, you name it, right? But those systems create visibility. They do not automatically create better workflow. And so engineers are still spending too much time analyzing, pulling data, validating that data, interpreting large volumes of information before they can decide what matters. And that's a massive hidden operational tax. So we are seeing highly trained engineers losing critical time switching between systems, extracting data, cross-referencing conditions to try to explain what happened. The cost is not just inconvenience, right? It's slower diagnosis, it's slower action, slower explanation. And in many agencies, this workflow is still reactive, right? A complaint comes in or a corridor underperforms, a device becomes unstable, or a safety pattern starts to emerge. Then the engineer has to open multiple systems, narrow that time window, compare signals, pull context, and start to build a defensible picture. Now, something we found in the 451 research, it notes that many urban mobility efforts are still reactive, often driven by bottlenecks, political pressure, complaints, or grant opportunities, rather than long-term strategic planning. But there's simply too much to do to keep operations running and too little time to get ahead. So that's the paradox, right? More data, not automatically meaning more capacity. And the reason is not simply volume, it's also fragmentation, right? So if we go to the next slide, what we're going to see here is the real burden is this fragmentation problem. The research material points to a deeper structural issue: siloed systems, fragmented data, reactive operations, all combined with that budget pressure. And so the challenge is not the lack of information, it's the need to understand and respond to an issue that spreads across these separate systems and workflows and even teams. When that happens, the human becomes the integration layer. The engineer has to determine which sources matter, what sequence to follow, what comparisons to run, how to assemble this full picture. And this is not a scalable operating model. What is changing now is not just awareness of AI, though. So another thing we found in the 451 research report describes a shift from passive monitoring to active orchestration, from systems that simply present conditions to systems that help retrieve, correlate, summarize, and support action. It also frames AI as an orchestration layer for safer, more sustainable mobility and a move from reactive operations toward more predictive and adaptive ones. Now, I want to be very clear. That does not mean agencies are suddenly becoming autonomous. It means the software can start reducing the burden of fragmentation so staff can spend less time stitching context together and more time applying their engineering judgment. And with 38% of government organizations already in pilot phase and 24% reporting scaled deployments, this shift to AI-assisted operations is already underway. So with that, I do want to do another poll. If you could quickly tell me where your organization is today with Gen AI adoption. Are you no current plans to adopt Gen AI? You're kind of here because you're research and planning. Maybe you're already in a pilot phase, or perhaps you already have scaled Gen AI deployments. I think this is going to really help us get a quick read on where everyone is today and compared to what these research studies are telling us. Where are you in your journey? And if you're not planning and researching, are you scaled? I think this is going to be a good checkpoint for us to get a sense where agencies are and maybe also help us too with how much time we should spend in these feature sections when we start breaking down the different types of AI. All right. So this is lower than the research that we've seen, but very interesting, with almost 30% no plans to adopt, 41% research and planning. What is super interesting, though, is that almost 20% in pilot phase and 12% already have scaled with Gen AI. So very, very interesting distribution with indication that we're still very much in that early adopter phase. All right. So moving forward, I think it's important for us, before we get too far, to define our terms precisely, because AI is often discussed as if it were one thing, and it absolutely is not. AI is a stack of capabilities, and each type of AI layer solves a different kind of problem. In transportation, that stack includes things like analytics and optimization, machine learning, computer vision, automation, and of course, generative AI. Those categories overlap in some places, but they're not interchangeable. Analytics and optimization help agencies monitor performance, apply rules, manage thresholds. Machine learning helps find patterns, forecast outcomes, improve prediction. Computer vision interprets imagery and video, detect objects, incidents, near-miss conditions. Automation handles repeatable actions inside defined workflows. And generative AI works in a different mode altogether. It is strongest when the task involves language, explanation, synthesis, and question answering. Now, this distinction matters because when people hear AI, they often jump straight to Gen AI. But transportation agencies are already using multiple layers of this stack at once. In fact, the AASHTO survey that Brent mentioned earlier reflects that reality. Agencies reported activity in generative AI, computer vision, and expert systems, as well as data analytics or machine learning, which tells us this is not a single tool conversation. It is an evolving mix of capabilities being applied to different operational problems. So the key framing here is this. In traffic engineering, AI is not that one monolithic technology. It's capability stack. And understanding that stack helps clarify where Gen AI fits, where it helps, and where it still needs other systems around it to become operationally useful. So I want to dive a little bit more now into Gen AI, right? Because Gen AI is the newest and most visible layer in the AI stack, right? It's the hot topic of the industry. And it is also one that creates the most confusion because it sounds, the technology itself, when you interact with it, sounds intelligent very quickly. You likely think about ChatGPT, Gemini, or maybe Claude. Now, the best way to think about Gen AI is as the language and reasoning layer. It is very good at understanding natural language, working through unstructured information, summarizing complexity, explaining outputs, answering questions, drafting communications or plans. That is why most early use cases look familiar, right? They're the chat interfaces or the co-pilots or the document assistants, maybe a knowledge search tool or a support or service bot. Those are natural entry points because they take advantage of what the technology already does very well. But this slide is equally important for what Gen AI does not do well on its own. A generic large language model, and a large language model or LLM is essentially what powers Gen AI, does not understand network context by default. It does not know your corridors, your intersections, your controller settings, your asset history, or your operational constraints unless it's connected to those systems. It also does not safely execute workflows on its own, and it certainly does not remove the need for validation. And this is a critical distinction. Gen AI can feel highly capable, but on its own is still mostly assistive and highly prone to hallucination. In transportation, it becomes genuinely useful only when it is connected to the operating environment, grounded in trusted data, and used inside a workflow that is reviewable and human guided. This is not about treating the model like an answer machine. It is about understanding what the model is good at, where it needs context, and how it becomes more useful when paired with the right systems and guardrails. All right, so now that we know Gen AI, let's talk agentic. What is a Gen AI agent, or what is agentic AI? This is the central concept in this session, so I want to spend some time here because this is where the conversation shifts from generative AI to agentic AI. The simplest way to understand agentic AI is that it combines three things: a reasoning engine with memory and tools. The reasoning engine is what interprets your intent, works through a problem, plans next steps. Memory keeps the task coherent as it unfolds. It remembers what is being analyzed, what information has already been retrieved, what comparisons have been made, and what stage of the workflow it's in. It remembers things like what you chatted with it about earlier, or maybe even in another conversation. Tools are what make the system operationally useful. Tools let it retrieve data across systems, access telemetry and safety information, or maybe do things like build charts and tables, or do mapping type visuals, pull documents, and support structured workflow steps. Once those pieces are combined, the system can do something meaningfully different from a one-shot assistant or Gen AI system that's outside or disconnected. It can help complete multi-step investigation. It can hold context across the task, move from one step to the next, and use the right connected resources to support the user along the way. It's also very important that it be very precise on like, what does agentic mean? And I think a lot of times when people hear agentic, they think autonomous. Agentic does not mean autonomous. It does not mean unsupervised engineering judgment. It does not mean handing over consequential decisions to a model. It is not automation. What it means is that the system can think through a task, retain context, and use tools within defined guardrails, while a human remains accountable for validation and action. That distinction is essential in this space because the value is not in removing the engineer. The value is in reducing the manual burden that surrounds the engineer. All right. So now that we've defined that, I'm going to pass you back to Brent, who can get into more how we can apply this in this industry.
That's great, Gavin. Yeah, it's really important to define those terms because often they can be misunderstood. So that's a great baseline to work from. Agencies, to some degree, already know this. They already know where they believe AI can help. Part of the research paper that we've been referencing shows that it's already being rated as a strategic application or strategic tool where it can focus on areas like safety and incident detection, data analysis and decision making, traffic management and optimization. These were the top 3 areas where agencies believe that it can add the most amount of value. And I don't know, consequently, I guess in parallel to that, most of the transportation master plans that we have seen over the last 10 years also reflect these as their major goals. So if all of the funding and all of the goals are aligning to where we need to focus the most amount of energy and the most amount of data collection, it's just logical that to now actually take action from that data, that's where we should apply Gen AI tools to actually make that impact. So for that reason, we actually look through how it was rated and how opportunities were identified for fast value creation. Traffic management was actually number 1. And this is where the complex systems come in, when you're working across different types of platforms or different types of legacy tool sets or the evolving technology that is out in our field and just trying to keep them optimal. It is true to say that not every agency can fund everything equally, which means very specific areas get more funding than others. But the data that can be produced continuously across the network, regardless of the differences in technology, can be leveraged into unified data platforms that can allow for ATMSs to coexist, ATMSs to provide alerting and value, but also allow for a data layer where an AI tool can be applied. Whereas data analysis was high on that list as well as a close second, where not only just connecting for traffic management and optimization, but actually getting through that data. That is a clear opportunity where this can be applied. And then lastly, safety and incident detection, while they come from sensors that are deployed in a lot of ways, there's also a lot of comparison to historical data sets and how we look at the current environment versus the historical environment, how we make decisions around how we design our roads. All of that comes from a comparison of today versus the past. So it is clear that how we're talking about this, and it's clear that we're getting into this topic because this isn't a new problem or this isn't an invented problem that is looking for a solution. It's the demand for something like this already exists. We're already trying to figure out how to do this as an industry, and hopefully throughout this discussion, we'll start giving you some more examples or start showing you some pathways to actually get to a reasonable adoption of these tools in your everyday life. So as I was kind of saying, this maps directly into the workflows today. So it's not necessarily a new concept of what the day-to-day operations are. Investigations already have multiple step processes. You identify a problem, we refine the location, the timeframes that come in often through citizen complaints or political scenarios. We compare the conditions, we pull the data, we look for likely explanations within those data sets, we communicate what we're going to attempt to do, and then you start measuring before after of changes made in the environment. This logic is already very familiar. Like this is already the processes that cities follow. Agentic AI does not replace this. It supports it and accelerates it. The value in using these tools or using Agentic AI is to reduce the friction between these steps, to start working alongside you, spend less time gathering and stitching the data sets together, and less time reacting to the complaint or the issue, and allow the system to retrieve data for you and start gathering and stitching it together. And then you can spend more time interpreting it, prioritizing it, and deciding what to do as a countermeasure. It's not just about having the data, it's about contextualizing the data, making the decision, and then making our roads safer and more efficient. The workflow remains recognizable. The amount of manual effort is significantly reduced to move through it. Many cities have a massive backlog of citizen complaints, or some of their citizen complaints can take up to a year or two to actually resolve just because of the load on some of our agencies. So this will really help accelerate the work and create a workflow optimization approach to leveraging these data sets. So here's a little bit deeper into the practical terms of what that actually looks like. And there is a lot of ways to think about this, but there is a surprising amount of time still being spent in what I call data hunting. They're looking for an answer. They're still gathering up information between systems. I often, sometimes think about this as the 6-monitor problem. You'll go into a traffic management center and you'll see a lot of individuals sitting in front of a lot of monitors trying to stitch these pieces of information together, exploring data, gathering information, and building a working theory of what they think might be happening. So this looks like receiving alerts, engineers review them, they open up all those tools, they start manually searching through them, they export CSVs, they take from social media, they put in pieces from here and there, and they cross-reference all of those things for insights, and then they build that working theory up. From there, they can then attempt to write a report or write a timing plan change and deploy it. And following that is almost sometimes hope. They almost hope that it actually had the impact that they wanted it to have without necessarily measuring it continuously afterwards, and then revisit that on some schedule down the road. A lot of what AI can provide to us is accelerating these steps. So in the world where Gen AI agent is taking on some of the activities, the issues come to the engineer already reviewed, synthesized, summarized in plain language. They already come to you gathered, already somewhat understood in a plain language. Was it a valid issue? What is there to investigate further, or what may be missing from it, already served up to you. Then you can interact with that data conversationally. You can start looking at it, testing different variations of it, see how it works, and get more structured, relevant analysis from that through all different connected data sources. So gather it up all for you. When it's all automatically cross-referenced as well, when you look at, say it was an incident scenario that you're trying to address from a incident that happened at an intersection, it's already working ahead and cross-referencing historical data sets. It's already trying to build the likely clauses, anomalies, or potential fixes or countermeasures. And in many cases, some of these things that we use as countermeasures don't have continuous policy around them as well. So they take deep thought and deep decision-making on how do you countermeasure a safety issue. By allowing AI to work its way through all the data sets, you can focus on the policy and the countermeasures to create safer intersections, validate that that's going to work, and make that change out in the field so that we can see before-after type data. And then ahead of you, after those changes are made, Gen AI is already looking at the before-after impacts of that information. So not only are you following the same workflow in your issue resolution or optimization, you're now accelerating it. You're starting to be able to capture 10 times more issues. You're able to resolve them 10 times faster. You're able to communicate with your public 10 times faster and work through bringing your community a better experience overall. The AI handles and delivers on the heavy lifting part of the challenge, and the engineers do what they do best. They decide, they make changes, and they make things safer. So last poll question for the group here. What is the biggest foundational barrier to adopting Gen AI in your agency? It's all often easy to say that it's a great tool, it's a great application, there's others talking about this, but what are the realities, or what are the things ahead of us that we need to start thinking about or start working our way through? Some of the common things that we have heard you can see here in the list. Um, lack of policy, lack of knowledge and education, lack of capacity or budget, data security concerns, trust and reliability on the outputs. A lot of times the outputs, uh, sound great, we want to make sure they're valid. They're actually coming up with good data sets. Sometimes your data is just not connected. You're right at the beginning of your journey, and you have to start with building out your ecosystem to then layer it on as well. And then lastly, with every AI conversation, the same thing always comes up. I am worried it will take my job. So these are all things that we think about. I'm very curious of how the group here thinks about some of the barriers. And once we're done responding, we'll take a look at those results. Almost. Oh, there we go. Oh, great. So we got a good amount of responses there. Luckily, no one thought that it's going to take their job. I'm happy to see that. Lack of policy and lack of knowledge and education are the common ones that we hear, and those did show up in the top three. And then trust and reliability. I think trust and reliability is one of the more common ones that comes up, just to make sure that the responses that you're getting through a chat interface or the responses in the compiling of the data is valid and verifiable so that you can make decisions from. All right.
Yeah, and that poll closely reflects what Ashto saw as yeah, you can go to the next slide. It's okay. The Ashto data was saying very similarly, right? That data quality and availability was noted as a top barrier. Cybersecurity was close second, and then trust and reliability, 61, and then lack of skilled workforce, which I translate to there's an education gap here on generative AI that needs to be shored up. And it's interesting. I think the poll reflects a lot of those same concerns. But Brent, I was like that before and after slide, incredibly impressive on the time savings between the old way and the new way. So there's clearly a lot of incentive to overcome these challenges. So let's talk about them. Transportation is not a soft use case environment for Gen AI, right? It's high context, high consequence domain. And that is why adoption is harder here than it is in the generic enterprise space. The first challenge, of course, is that integration wall. The information that matters often lives across signals, telemetry, cameras, safety applications, performance systems, all kinds of other external inputs, maybe probe data, etc. Those systems are often not natively connected in a way that makes investigation easy. The second challenge is, of course, the context problem. A useful answer depends on very specific details. Access to that corridor information or the intersection, the time window, the hardware configuration or the timing plan, or maybe operational history. Without that context, even a fluent answer can still be the wrong answer. And then the third challenge is trust and reliability. Public agencies need outputs that are explainable, reviewable, and defensible. They cannot rely on kind of a black box logic in consequential workflows. And then fourth challenge is the workforce readiness. Even if the technology is promising, people still need support, training, and practical experience to use it well. So Ashto's survey data reinforces exactly that picture. And these are not cosmetic issues. They are foundational constraints. So the question is not whether agencies are interested. The question is whether is the data, the security model, the governance, the workforce enablement, are they strong enough to support adoption responsibly? So if those are the barriers, then let's talk about the path forward. So we need to move from the integration wall to what agencies need, and that's a unified, connected data platform. That means an operating layer that can bring together network telemetry, sensor analytics, mobility studies, probe data, and other relevant sources into one workflow, into one place. For the context problem, What we need is network grounded intelligence. The system has to be able to reason inside the real corridor, the intersection, be able to see the asset, the time window being investigated, rather than answering in generic terms. From trust and accuracy challenge, we need explainable human guided workflows. The AI should be able to retrieve, compare, and summarize within guardrails with humans in the loop to validate findings and make responsible decisions. And from the skill gap perspective, we need guided adoption and workforce enablement. And that means training, day one usability, contextual prompt guidance, and pilot friendly workflows that help teams build confidence without needing to become AI specialists overnight. Now, AASHTO's roadmap language aligns with that approach as well. They talk about how agencies need specifications, governance, oversight, transparency, auditability, and continuous validation as they mature their adoption model. So this is the standard for engineering grade Gen AI. The goal is not autonomous traffic engineering. It's connected, grounded, explainable, and adoptable AI that agencies can trust and teams can actually use in the real world. So with that, Brent, maybe you can talk to us a little bit about real world Gen AI.
For sure. This is where it starts becoming real and exciting. So I did want to talk about the Miovision Gen AI agent. This is a tool that not only are we starting to see a significant number of cities starting to apply, we're starting to learn a lot about the applications and the outcomes that cities are already taking advantage of today. So this is Mateo. Mateo is our Gen AI agent, and it follows a lot of the principles that we talked about so far in this discussion. It comes in essentially two different layers. So the first one is Miovision 1 is think about the platform that integrates all the components together. The integrated citywide data systems, think camera feeds, all your sensors, the data flows that are collecting. Those are systems that exist in parallel on top of each other and sometimes embedded within each other. Then there is on the far right, the infrastructure and policy management side. How are we allowed to make choices from? These are rooted in industry, engineering policy. Think like FHWA standards, MUTCD manuals, HCM manuals. These are the rooted pieces of policy and active transportation items that are actually working. Smart traffic signal controllers, adaptive speed management, all the major components of how our streets are managed today. And then in the middle of all these components is you have a large amount of data being produced. Performance management, demand management, signal optimization, are all the components in the middle. And it starts with this layer, connecting everything together, bring that data together, create a unified model that a Gen AI agent can actually operate on top of. And that's what we are talking about in our platform. And it's also what is being launched to the world here in the next couple of weeks. It started out as a chat interface. So you can see on the right there, Mateo on top of it started out as a chat interface, but it's starting to grow with these use cases significantly and starting to become an accelerator of optimization through these different workflows. And it takes that complexity. So here's a little bit of an example of looking at some basic information that you can compile. So transform a complex amount of data set, but a clear question, like a simple question, but a complex data question in the sense of where is my highest amount of pedestrians that exist in my network, find where the top volumes are and plot it on a map. An engineer doing that or a staff member doing that could take days or weeks to actually compile a report that looks like that from multiple sensors. At your fingertips and within seconds, you get the answer and the map in real time. And it's a very interactive tool. So what Mateo is effectively doing is compiling that. It's starting to connect the dots of both the systems that Miovision has, but also the systems that many different vendors have and integrating cohesively to the ecosystem. And it bridges this data set into our agencies that we're working with, and they're scaling their workflows around that. So again, it is not acting autonomously, but it is allowing the human in the loop framework to accelerate. And it's allowing the human to get their task done. It's allowing to apply the data sets to determine root cause analysis in minutes, not days or weeks, and accelerating those investigations. It's a very exciting opportunity for many cities to take advantage of, and we're starting to see that take off right now as well. So there's a couple pillars of what this value actually means that often I use as a foundational component to think about where is it layered. So scaling the efficiency. So we often talk about the staff part of this challenge, allowing the staff to operate at the peak of their capacity. So high strategic work, not busy work, in moving their value up the stack of delivery, unifying the intelligence. So actually combining all those data pieces together. Lots of different technology vendors talk about unified data models, but they only produce one piece of the puzzle. You need to think about the whole problem and unify it together to a cohesive record. And then get into the root causes, actually get to what is happening in the infrastructure with full context and flagging exactly why it's happening or where it's happening so that you can get to work, so that you can get to work on the root of the problem and create that outcome. And then ultimately, the public impact, making sure that we are improving our roads and we're staying on pace or growing along our communities and move from defending our budgets that we're trying to hold on to operate our platforms to demonstrating real value to the community that can become a different type of political landscape where we can show the impacts, where we can improve safety, we can reduce fatalities, and we can actually show that happening in a more real-time approach. So a couple other layers to that are just different applications to think about. That is the multi-use case. So not just one thing. When you think about a TISMO or transportation system operation, a area that you're operating, there's roads, there's dense urban, there's arterials, there's highways, there's interchanges, there's event spaces. There's a lot of different tools we need in our tool belt that an application like Mateo or an Agentic AI tool can start pulling together. This way we can become proactively, we can address safety concerns proactively. We can get ahead of them, potentially saving our lives. Maintenance and efficiency, so keeping the lights on. Many of the communities that I work with have to rank and prioritize which maintenance problems they solve in an aging infrastructure. Many cities have been around for hundreds of years now, and infrastructure has a constant upkeep. So how do you prioritize? How do you use your resources efficiently and prioritize them? Performance optimization is even evolving in context generally. Before, we used to talk only about how do we make vehicles drive faster, further, safer, and only focused on vehicles. It's a much more complex problem now of optimizing vehicles, the movement of goods, pedestrians, scooters, the more vulnerable road users on our roads, and making sure that everything is balanced and optimized, and then ultimately produce high quality mobility analytics around those users to make sure everybody's getting where they're going. There's lots of different charts. We talked about different charts and executing complex technical analysis. The way we might be presenting data for a performance evaluation may not necessarily match how you want to report on it. And this is a great opportunity for Agentic AI to actually formulate things in the formats that you want, actually show it in the context, look at it in the way you want it, dissect it in the way that you need, so that you can really look at all of this, maybe an example here, all of the cycle failures or performance split failures that are happening across entire corridors, across entire networks, and think about level of service at a whole nother level than we've ever had in the past. Combining that with safety, where we often have performance problems with movement of vehicles, you often see people taking more risks, like running red lights or turning right on red when they probably shouldn't be, and creating unsafe scenarios for the vulnerable road users, especially in high-speed scenarios. So contextualizing both those two things together and making sure that we're optimizing in the complex analysis, both those things together. And then lastly, emergency response is a very common challenge for every city. How do you get a fire truck through that problem, through that network in the most safe, efficient way to save even more lives? So these ecosystems of unified active platforms like a Miovision One platform integrate connected vehicles with data sets and safety evaluations all at the same time, which create a great opportunity for AI to help accelerate. Again, the workflow is the same. We're not replacing the existing workflow, we're accelerating it. We still identify a problem, we diagnose the problem, we use a tool to help us accelerate the collection of the data and diagnose the problem. We come up with a resolution and apply that resolution and then validate it. All of these steps are common, and using the tool to actually deliver on that at an individual complaint or individual intersection is going to be accelerating it. But start thinking about it at scale now, thinking about it across a whole city, a whole district, a whole DOT, a whole state. Now you get to a continuous unified model cross-jurisdictionally, accelerating not just your processes within your agency, but your neighboring communities. You're accelerating the amount of information you can share, the amount of optimization you can collaborate on. And so you go beyond an individual complaint to a citywide intelligence reporting platform that can be connected into other jurisdictions and other departments within our communities to help everybody be better. It's all boats rise with this type of application, and it will be really exciting to see how it's taken effect. So last thing I will show is a quick little video here. Mute that if that's actually playing sound, I'm not sure. So this is a little bit sped up just to kind of show you an example of it. This is actually what the platform looks like in one of our partner cities, the city of Detroit. Our relationship with the city of Detroit's been going on for well over 10 years now, and they have a connected, unified platform in their city now, and they have a large data set to look at. If anybody knows the history of Detroit, obviously they are the Motor City. They have grown significantly, they have shrunk significantly, and now they're starting to grow significantly again, which means their data challenges are in both directions and in all complexities. And now they have a cross-section view of their city in a way that they can ask questions directly on top of their infrastructure, asking around let's go back to that video playing. Show me where the top 3 intersections have the most performance-based problems. Or in engineering terms, the most split failures that occur in the last week. It can quickly compile that answer, allow me to target my energy in a large network environment. It also services where I should be looking at the most and what suggestion I could even start with, or where I could go next. Maybe I should investigate timing or provide recommendations to reduce these complaints. And it can immediately start looking at all approaches, all movements, and start providing a quick recommendation. It's not doing it in a closed box either. It is showing you its thinking. It is applying the data sets. It's allowing you to interact with the data sets in a way that when it comes up with its final recommendation, you actually know where that information came from. You can validate the data sources and determine how you want to solve the problem. So I'll play it one more time just because I know it was moving a little quick, and then we can get into a little bit of a roundtable discussion. So when you do a chat-based interface, or when you're looking at a conversational interface, we ask plain language questions. We ask, where are the most problems, or what is the most unsafe location? And I want a recommendation. It doesn't necessarily solve the whole problem in a simple prompt, but it guides you into more details about your questions, or it gives you suggestions, or starts taking you down a workflow like a warrant analysis to help accelerating your process. And you can see that just through the click of a few keys, you start getting your answers and your charts right away. You can interact with them, you can explore them, and you can start executing recommendations that it provides, or using methods to validate that it's correct. So it even suggests that what you assumed was the problem was not actually the problem. So having a tool that has that deep-rooted knowledge around traffic engineering layered in with the data that's actually being produced from your network can create the outcomes in real time. So that was a quick demo of what this can look like in a practical world in one of our partner cities that we work with really closely. Really excited to show you that. Maybe what we'll do now, if this will click.
And Brent, one of the things that didn't show in that video, but one of the things I love about Mateo is its ability to correlate different data sources, right? Like things that don't even exist in a view in Miovision 1, Mateo can compile data into unique views that, don't exist anywhere else and can even reference outside data. Like if you ask it, find find the most split failures near schools as they're letting in and letting out, it can actually go and find the proximity using map data to schools and look up online when those schools hours are for open and close. So it can really do a lot of cross stitching, not just within the data in your network, but even outside of it to public data sources as well. It's very powerful.
Very exciting. Yep.
All right. Well, Brent and Gavyn, that was a fantastic presentation about sort of the concepts and context for AI tools and traffic management. You got a little taste of Mateo. I'm hoping that all of you will contact Brent and Gavyn to get a little more detail about how that tool works and how it might apply in your cases. We'd like to take just a couple of minutes now for a little interactive discussion. And it's on the topic of how to get started with the use of these AI tools and what are some of the challenges. And we've made reference a couple of times to the AASHTO survey and some of the AASHTO materials. I wanted to make sure you know that if you go to the resources tab at the bottom of your screen, you'll see a little pop-up that has some links to this AASHTO survey that we referenced, which talks about some of the challenges and sort of status and challenges of use of AI. This is a survey of state DOTs. Useful stuff. And there's also a link there to AASHTO white paper. So take a look at that. But just take a couple of minutes here on this topic of sort of barriers and then challenges and how do you get into the use of these tools. Talking about such topics as what do you need to have in place to even start and consider the use of AI tools? What are some of the blockers, technical or institutional, to adopting these AI tools? What do you need from vendors? How would you go about structuring a pilot that can maybe prove the concept as well as get support and resources to move ahead? So I'd like to get your ideas and questions. I'm talking about the audience here, particularly those of you who have thought about AI or doing some planning or have adopted AI tools, what you've encountered. And maybe to kick this off, Brent and Gavyn, you could pick up on this theme and maybe react to some of these based on your experience with particular jurisdictions.
Sure. Maybe I can start and Gavyn, you can build on it. When we first started going down the path of talking about layering this into our platform or into the workflows that we know the agencies are trying to tackle, the first two that you even see on the slide here, those were kind of the main ones that came out initially. So at first, they wanted to make sure that they could trust data and they didn't know how to validate it. There wasn't as many peer reviews available. So they felt a little bit on their own in making a decision, which kind of led to the second part of the challenge, which is many of the agencies are still formulating their AI policies and maybe layering it into data security processes or procurement processes to help make decisions through committees. But to some degree, that almost created a barrier just to start, right? Like that created that moment of uncertainty of, can I, should I, how do I? And that adds a lot of delay to just getting active into the tools and experimenting with it. It is probably the most common. I think immediately what I did see afterwards, though, once they did get into the tool sets, you start seeing an interesting layer of knowledge, the approach to how they start learning how applications can help. And so when they know the question that they're trying to ask, think like, where is my congestion? Getting a quick answer, getting a very comprehensive answer to their question without actually knowing how to use data platforms or actually how to navigate data actually became something much more powerful than any of their hurdles that they actually faced. And so really the two major things that I learned through that process is that while a lot of the good parts on the other end of that actually immediately have those types of impacts, that starting point or that first hurdle just to get going is where a few of these agencies get hung up on and making the decision to start.
Yeah, I agree, Brent. I think you kind of hit it. I think that it's try not to overcomplicate the readiness is pick a use case, establish some guardrails and um, start testing what those first use cases are and see how it works in your environment. Um, I think it's good just to jump in and see what it can do for you.
Okay, well, we've got a few questions pertinent to this topic of barriers and how do you get started. So I'll go over a few of those. A question from Mark. Most of our data still lives across legacy signal systems, third-party vendors, disconnected tools. What does a realistic first step look like to implement agentic AI without a full platform overhaul? Probably something everyone is facing.
Great question. I mean, I can imagine every agency has, to some degree, still this question because you do see very rarely an agency that has fully upgraded infrastructure. It's usually done in batches or in spots or in prioritized approaches. Um, One of the best things to do at the very beginning of choosing a new technology is standardized technology or standardized protocols. That has got to be the fundamental layer to a lot of the decision making on which technology is, whether that's a NEMA standard or NTCIP standards, just to get data feeds from the field or just to get access to polling of intersections. Having more modern controllers helps quite a bit. There are interface options that are more of the expensive path to adding layers to keep legacy hardware alive. Um, that can work for a period of time, but often just upgrading the traffic controllers and the infrastructure gets you a far way into creating a common data set. And most agencies already know this. They're already going down this path. And then the last leg is just the communications themselves. Communications can be often thought of as expensive fiber networks. There's simpler approaches to connectivity or connecting in the ecosystem, and that doesn't necessarily require advanced controllers. It requires basic communications that everybody can get off the shelf and leverage, and we try to simplify that with some of our technology. Lastly, the final leg of that is using those standard data feeds and using the data that's being collected from the field and the sensors into a common data model. And that's where the platform you choose is super important. Having a platform that leverages those standards or leverages those interfaces and those integrations through the standard protocols. It allows you to interchange the technology as you need with your standards while leveraging an interchangeable platform so that you don't feel like you're locked into any particular vendor, but you are maximizing the data that's being produced in a very standardized way. One of the worst things you could probably do is do proprietary things, like do things that are custom to you or custom to your network. Standardizations allow you to maximize the value quite a bit and just start working your way through the network. Whether it's starting to look at data sets being produced from 10 locations, scale to 20, go to 30, go to 100, just start working your way through it and connecting in that ecosystem.
Okay, great. Another question from Mustafa, pertinent to this topic. Can you speak a little bit more about what kind of data inputs you need to do this level of analysis? You can speak with Matteo. What are the key data feeds that you really need to focus on in implementation, at least initially?
Um, there's a couple different ways to think about that. One of the most common sources I would say would be the traffic controllers themselves. The traffic controller aggregates just not just the signal timing, but the sensor inputs to the signal timing. So think actuation or um, upstream or downstream detection, maybe push buttons, like all the things the traffic controller is operating with. The traffic controller aggregates a lot of that together. And a very common tool set is called ATSPM, so Automated Traffic Signal Performance Measures. Those are almost table stake type data sets that are produced completely by the controller itself. And so if you didn't even have robust or advanced sensors or third-party platforms providing with probe data, your traffic controller is such a goldmine of data on what the current operation is. Start by connecting the traffic controller, and a lot of applications get unlocked from there. And then you know where performance is working and or how well you're servicing your demand, or how well or where you need to focus to improve your optimizations just from your existing infrastructure without over investing in new infrastructure. Just start pinpointing where you do need to invest. And that all comes from just connecting in your traffic controller into a platform like Miovision or like an ATMS.
Okay, one more question on this topic. If we were to run a 90-day pilot, what sort of use case would we define? What would be the objectives? How would we set that up to get that done, which would be a good, again, illustration of proof of concept as well as generating support for the use of these tools?
A 90-day pilot is a good way to think about it. You probably could get a lot done within 90 days. We launch 90-day pilots because often the workflows that we talked about earlier in the presentation as well, like those workflows are well defined. So you can start with what is your existing workflow. And one of the most common ones that pilots tend to form around is the citizen complaint challenge. Citizens complain, they come up with either real things or like real things or fake things, depending on how you think about the problem, or unvalidated type issues. Start with a simple workflow of how do you resolve citizen complaints, or how do you resolve the need for analysis as they come up reactively, and start streamlining your reactive approach. And the pilot could simply be that focus. Just how do I improve my ability to respond to my citizen using a tool and platform like this? That's a very basic pilot. It could be done immediately. It's already an active operation in every city today, and it's plug it in and start connecting the dots and start accelerating through. Obviously, there's more complex pilots that you can undertake, like using sensor systems that are doing high resolution near miss analysis, very deep rooted analysis and detection. And I have seen a couple pilots formulate around that, in the sense of how do I combine my historical crash data, my community census data with my near miss and current predictive data, and how do I put all of those together to understand a safer model and design new policies. Those are probably the most complex pilots you can do with AI, but almost the most rewarding when you get through them. It's just maybe not the best place to start right out of the gate. Think of the different workflows and challenges that you're working through. Take a small step in and start optimizing.
Okay, great.
And Brent, I'd say too, like some of the use cases that people tend to gravitate to and maybe don't even think of right away is like asking simple questions like, which of my cameras are, are blurred by weather, or which of my intersections might be inconfigured or configured improperly or not fully. And the AI can do a network-wide sweep on your sensors and your config and tell you where there might be areas for improvement or where maintenance needs to happen.
Yeah.
Right. Well, I think we've got a couple more slides. Then we're going to take just a few minutes with some general Q&A and wrap things up. So back over to you, Brent and Gavyn.
Great. We'll keep it quick because I know we gotta wrap up here, and I want to see if there's any Q&A. So as you start thinking about your approach to this, the process to decide of how to use AI is not that much different than our security and data processes. It comes almost like a checklist and almost second nature around safety or around security today. And think network security and IT security. Those processes have become much more mature over the last 10 years. And what we're realizing as we launch AI tools is that the process is basically the same thing. You ask the same questions, you structure it in a standard way. Does it access public training sets, or is it only trained on my data? Is it isolated from the outside world, or is it only in my environment? How is it encrypted? Where is it encrypted? What permissions do I have? What access to the outside world do those things have? Is a human in the loop, or can it execute on its own? Those are very important questions to include in your policies and include in your data security questionnaires as you're working your way through with vendors. And don't be shy to ask the questions, and make sure the vendors are documenting the answers to those in ways that you can hold them accountable to it, because these are critical components of adding not just unified data models, but AI tools on top of it. So it's super important. We talked a little bit about this through just that round table there, but practical paths forward do look like pilots, but often you see it kind of happen in 4 steps. One is you start talking about your AI strategy. That's kind of what we saw in some of the polling questions here. People are researching, they're trying to understand what their strategies are, what the workflow force impacts are, identify decision makers, establish a skilled industry partner, whether it's a company like Miovision or someone like an industry partner that can help you through this, and then pilot it. Actually, just go through those stages of piloting it, see what it can do for you. See how ready you are for it as an agency, how you can work through enablement, implementation, and start unpacking those and really get to those proof and ROI case studies. Like really show that value. It's amazing how some of the agencies that we have worked with can get the 10x resolutions and ROIs really rapidly. So just start those pilots, start getting into it. That'll teach you how to do governance, how to inform your policies, how to inform your procurements and your committees, your architectures, your specification. All of those will become natural outcomes once you get started and once you get into it. And then the last part of the journey is at scale. You start seeing a complete network. You start seeing it unified. You start seeing change management starting to occur. The change of the operations starts getting way more exciting, and we really start seeing those impacts accelerate as well. And I'm really excited to see. I think we have well over almost 30 agencies now starting to engage in these applications with us, and I'm excited to see many more agencies take the step forward and jump in. So maybe I'll stop there, and we'll get into some Q&As
All
from
right.
the audience.
We got a very short amount of time for some questions. I'm going to really just do one question. We've got a number of them posted, and I'm going to ask Brent and Gavyn after this webinar to actually respond in writing via email when we get it out to participants. So let me just do one of the questions here, a good one. Can you control Mateo's behavior with extended prompts, similar to a custom chat GPT or character prompt? How does it work?
Yeah, so
give us the short answer to that.
Yeah, you can be descriptive with Mateo in a single chat. Like you can give it instructions. So you can control some of the context and within the chat window. But we currently don't support customizing the system prompt, simply because a great deal of effort and research and development has gone into making sure that Mateo has proper guardrails in place and how it interprets all of your network and traffic data.
Okay.
But I will add one thing. We are looking at ways to incorporate agency knowledge, guide files, config things, timing manuals, etc., into Mateo's knowledge set for each independent agency that uses Mateo.
I want to encourage everyone again to find out more about Mateo. You just got a little bit of a taste, but a whole lot of good information about sort of the background and concepts of thinking about AI and its implementation. So we're at the end of our time here. I just want to mention again that you will receive an email with a link to the recording for this webinar. You've got the resources tab with some of those AASHTO materials and some other links in there. I want to thank Miovision. Miovision as sponsor for putting this on, and then great presentation by Brent and Gavyn, and also Connect Me for sponsoring this webinar series. Brent and Gavyn, 30 seconds. Any other final words for our audience today?
Hey, I won't kick it too hard, but agentic AI is not autonomous AI, right? It's not automation. Be careful here. agentic really does mean thinking plus memory plus tools or skills, but always with a human in the loop. Now, tools can include automation, but those are different. So I'll leave you with that, and then over to Brent. What do you think?
Gen AI agents will 10x your capacity. I've seen it over and over again now. Automating data synthesis, stripping away your manual steps, move your teams efficiently to the analysis phase. This acceleration will have the impact quickly. And then lastly, getting started is easier than you think. It's at the fingertips now. We can get started. Pilots are easier. Leverage those industry standard checklists, collaborate with experts, and just get going, just get started. And we're excited to see what everybody starts doing.
Okay, well, we're at the end of our webinar. I really want to thank the participants taking your time. Hopefully it was useful, and best of luck with your challenges in implementing AI. Take care, everybody.
Thank you.
Thanks.